Hi everyone, in today's video I want to show you how I built this camping battery or just a backup battery, and this thing is an absolute unit. It has 2.5 kilowatt hours of battery capacity and a 3 kVA inverter inside, and also an MPPT controller to charge with the solar panels that I also bought. So this is all the stuff I ordered for the box. You can see the inverter and the battery fits in quite nicely. Now it is quite snug on the sides, but I'm hoping it would not heat up too much, because I am going to add fans to move air throughout the thing, and I will also not be pulling that much power from it, at least not for long durations. Now all these things I ordered, I have to try and fit in that box. Now I ordered timer switches, so I'm thinking of putting the inverter switch onto a control panel outside and hooking up a timer switch so it turns off after, let's say, 3 hours or something, so that it doesn't run continuously, because these inverters draw about 35 watts 30 watts of idle power, so it can eat your battery up quite quickly if you would forget it on, let's say, overnight or so on. But yes, maybe also I took up another switch to bypass the timer so it does stay on, but I'm not sure yet. And then secondly, I've got a fuse box. So you can see all these places you can put in fuses, and then they also gave me stickers so I can label all of the fuses. And these red LEDs in the middle will show you whether the fuse is still active or not, or blown. Then I also ordered one of these. So it has two USB-C outputs. One is a PD charging of 30 watts. The other is Qualcomm USB-A charging, and the other is just a normal USB-A. So I'm hoping this works quite well. But yes, I think this should be enough USB outputs for now. And then I also ordered one of these so that I can mount it on the outside and then get in the standard AC into the box to charge the battery. Now I also ordered this. It's just to go around all the wires that will be inside, just to neaten things up a bit. The next thing is this temperature controller for these fans. So I ordered two of these fans. These are 24 volts and they are 120 millimeters. So I got two of them, and they also come with this protective cover so that I can mount it on the outside. I'm thinking of mounting one on each side, so an output one and then an inlet one. And this, you can set the temperature at which the fan should turn on, so that you don't run it continuously. Now I will probably be also hooking up one of these switches directly to the fans so that I can turn them on to run continuously in cases where I will be drawing a lot of power from the inverter and so on, and I don't want to wait for the temperature to rise so this thing turns on. So it's quite nice. You can just set the temperature, it should turn on, and then also I think a temperature where it shuts off again. And then you can also see the current temperature inside. And also it's quite neat, so you can see with this out LED whether the fans are on or not. Next I ordered this thing. So it's basically just a bunch of switches which you can hook up to anything. It shows you the voltage. It also has two USB outputs, just normal slow charging USB outputs, and then also one of these cigarette ports where I will be hooking up my DC fridge. Okay, for the inverter I went with the Synapse 3.0V Plus, And the reason I went with this one is because, well, it's a 3 kVA inverter, so it's more than enough to run anything. You can run a coffee machine, you can run a hairdryer from it, basically anything. So it is not built for my use case where I'm taking it camping and everything, but it's nice to have that much power in these things. Now I bought this one for 3,000 Rand, which is quite good. I bought it off someone who bought it but never installed it. So hopefully everything still works perfectly. Now I just want to show you all the stats. So it's 3 kVA, 2400 watt, 24 volt. It also has an MPPT charge controller with a range of 30 to 80 volts at a rated power of 1000 watts. Now I actually ordered an MPPT Victron controller because the previous inverter I had, you couldn't use the solar charging while the AC output was off. While the AC output, yes, was off. So I bought an additional MPPT so that the solar charging still works even though the inverter is off. But this one, I believe you can still use the solar charging mode with the AC outputs off, but I'm not sure yet. So I guess I'll check if that works as good as the Victron. Otherwise I would probably just keep the Victron. Otherwise I would sell it if this one works as I want it to work. It's the MPPT I got. So it's the 7515 charge controller. It's not the Bluetooth version, so you can't see any info on the app with this one, but it should work fine. So how this 7515 works. So the 75 is 75 volts, so you can connect a maximum of 75 volt solar panel on it. And then the 15 amps, it's not 15 amps on the solar panel, it is 15 amps of charging the battery. So you will be able to maximally charge 15 amps at 24 volts. So I'm not quite sure how much that is. I think it's almost 400 watts, something like 370 watts or something, 360 watts I believe. So if you're buying a solar charge controller, just remember that is not 15 amps on the solar panels. It is 15 amps going into the battery. This is the battery I went with. Now this is quite a big battery, which is perfect for what I want to do. So this is a 25.6 volt lithium iron phosphate battery at 100 amp hours. So it's 2.5 kilowatt hours of power of energy, which is amazing. To give you context, you can charge your phone upwards of 150 times, which is ridiculous. And with something like my DC fridge, I should be able to run it for 4 days easily. So I think this is going to be perfect. I think adding the solar panels, it's gonna almost never go out. I might have to add another 100 watt solar panel, but I guess I'll see. Alright, I've connected everything on the inverter now. The positive and negative leads from the battery. There is no breaker yet on the positive line. I couldn't find one yet, but I'll go get one. Maybe like a 125 amp DC breaker. And then I've connected the AC. I don't know why they put the earth separate from the AC outs. Why it isn't just a terminal here, but I guess that works. I just had to make sure that is the earth for the AC out in the manual, but it is. So now I'm gonna turn it on for the first time. Okay, kind of stressed for a while there. I thought it was gonna turn on instantly. Almost thought it was broken for a second. Okay. Well, there you go. The output is showing 228 volts. I've also connected a hairdryer here. I'm first just gonna turn it on without the heating on. Okay, it works. Okay, let's see. With maximum heating, on this thing it shows 2000 watt, I think. Yeah, 2000 watt. So let's see. Okay, that is amazing to see. I think I also want to kind of try my coffee machine and see if that works, because having a coffee machine while camping would be amazing. A bit spoiled, but it would be amazing. So this is what I've done so far. I've added this control panel here. I just cut out the plastic, put it in, also with the screws, and then also an AC input, which will charge the batteries through the inverter. I'm not sure yet how many amps the inverter does on AC charging, but I guess I'll check it out later. I've checked online and I think it's 40 amps, so it should take about 2.5 hours to charge that battery. And then I've also added a fan as an input on this side. Now the thing is, it's quite a limited space inside. With the battery inside here, it's almost up to this fan, which is not ideal. The battery goes up to about halfway up the fan, and then the inverter is on top of that. So here is a bit of clearance at the top part of the fan, but not a lot of clearance at the bottom part of the fan. The thing is, there won't be enough space to add an outlet fan on the inside. So if I want to add a fan, I would have to mount it here on the outside. Again, there will not be a lot of clearance just in front of the fan, which is not ideal. But at the moment, I'm almost thinking about not having an outlet fan, but just having holes here and a bunch of holes here at the top. The inverter, of course, has two fans at the bottom of it, which blows out air. So it takes in air there at the sides, and then it blows it all out with quite powerful fans at the bottom. So I'm thinking of just having outlet holes on this side, and then hoping that would be enough airflow. Of course, getting fresh airflow through here, pushing it into the sides of the inverter, and it pulling it out and having the air go out. Now I will test that and make sure it can hold a load for, I don't know, 10 plus minutes at around 2 kilowatts, which should be more than enough for all my use cases. If it does overheat or anything, the inverter of course has an over temperature alarm, and it will shut off, so it won't overheat and break or anything, I believe. So I will be testing if the solution will be enough with the holes on that side also. If it is not, I will be adding an outlet fan that pulls out additional air at the back. But I'm quite happy with how it has turned out so far. Okay, so this is with the battery inside. So you can see there is not a lot of clearance, but it is around the halfway mark of the battery. And then on top here it will be a lot more clearance. On this side there isn't any clearance, so the fan won't be able to go in there. And then I also just bought one of these, which I think I will mount here, so you can easily plug everything in, and it is rated for 16 amps, so it should be more than enough. So I took out this control panel and I cut one of the wires that was going from here to here, and I used one of the switches to control this bottom part. So now when I turn on the right switch, it turns on all three of these, the 12-volt plug, the voltage meter, and the USB outputs. Alright, so I've wired up quite a few things now. So we've got the temperature controller, the fan is wired up. So how everything works right now is the temperature controller will turn on the fan once that gets, I think, to 26 degrees, and then it would switch off again at 25 degrees. So I'll just hold this in my hand to heat it up a bit now. It should be quite quick. Let's see, I think maybe 25.5, I can't remember what I set it to. Yes, 25.5. And then when this will cool off again to 25 degrees, it should turn off again. Okay, let's see. Well, I'll make this lower so it's quite easy to set. Just press set. Let's see. If it goes to 25.9, it should turn off. Let's see if it decreases again. Okay, so it's staying the same temperature now, but so yeah. And if I want to run the fan continuously, I also wired the switch up. So even though that is below temperature, I can still turn it on and just leave it on then. And then this is of course all of these switches that I showed you. Okay, so it's been a while since the last video, but I finished everything up. I added the XT60 connector for the solar panels, added the AC outlets, and just finished everything up. Now I've also made this wire, and this is from two 20 amp wires. So it's able to handle 20 amps, and they both have XT60 connectors on both ends. And I made it around 8 meters long, and also just added electrical tape all around it. So the reason I want it to be quite long is simply if you're camping and you're camping in the shade, just so you can connect your solar panels somewhere in the sun. I also made this connector, and it has the MC4 connectors for the solar panels, and then also an XT60 connector to connect to this cable, and then connect to the solar input. Now everything has worked so nicely so far. So I've went camping for 8 days, and at the start the voltage was 27 volts, which is around 95% fully charged. And then after 8 days it was at a voltage of 25.9 volts, I think 25.9, yeah, and that is around 35%. So I went from 95% to 35% over 8 nights, and I was continuously running my DC fridge from it. Keep in mind it was quite cold, like throughout the night it was around 4 degrees Celsius, and so the DC fridge just doesn't use that much power when it's that cold. But I've also charged my phone every day from it, and I've also ran a fan throughout the night, which is just a small DC fan from the USB outputs. But throughout that whole camping experience I did not even use the solar panels, so it just goes to show you how big this battery actually is. Yeah, so I think with the solar panels, if I had it there, I would have kept it full until the end. Now these are the solar panels that I bought. It is Aquasol 100 watt solar panels, and they are rated at a maximum power point for 40.6 volts. Now this is, you get two versions of the solar panel. This is the high voltage model, and the reason I went with the high voltage model is because each panel has 40.6 volts. I think you also get a version that is 18.6 volts or something like that. But the problem with that is you would need to have both panels in series connected to the inverter's MPPT, otherwise it would not work. So the reason I went for the high voltage panels is because if I only want to use one panel, I can use it with just one panel.